Okay, class, I hope that 1.1 and 1.2 went smoothly with you guys. So we are going to look at 1.3 of your textbook, which we will talk about new functions from old. Also, we will study about some transformations, even function out functions, and please review with the appetizer. So let's look at first function. As you see, I didn't actually draw the first function, my bad. So the function that I want you to have is an M shape, and then look at the coordinate very carefully. I will write this one 2, 2, and then negative 2 and 2. This one 0, 2, 0, negative 2. So let's do transformation of a review. So my whole function plus 3 means my original value of y coordinate plus 3 will make my function go move everything by 3. So it's going to be move up 3. So my x coordinates will be all stays the same, and I'm going to move my original function, which I had these 5 points, moving up 3, we will have these 5 coordinates from original. Sorry if my graph is a little bit off. And next one, I want you to see the differences. This time is together with x. We know that x minus 2 is equal to 0 when x is equal to 2. So this means compared to the beginning, you are going to move my original function by 2 to the right. So all these 5 points will be moved to right 2 coordinates. So now if you had your M-shaped original one with dotted line, now you see new function is going to be transformed to the right. So if you think about next function, this one is combined between these two and this one. So I can move by inside the parentheses will help me go right 2. And then as you could guess, next will make my graph move up 3. So either you can use this function already and move up 3, and then you can move right 2, or you already have a right 2. So I'm going to utilize this function. Same thing I had it before. So already moved right 2, so I'm going to move up 3 using those 5 coordinates. So now my new function has a shape of M this way. So these are the answers. Then let's look at next transformation. If I have a negative value in front of the original function, then what's gonna happen? My original one had M shape. However, this will make all my y values upside down by giving negative value. However, x value stays. So all my function is going to be reflected over x-axis. So think about this way. I used to have 2, 2, but x is the same, but y value is going to be changed to negative y value. Then keep applying the logic here. If I put negative outside the function flips over the x-axis, what's gonna happen if you have a negative inside of the parentheses? This will make all your x values flip it to negative, which means I had original function M shape here, and if I have this coordinate 2, 2, this will be negative 2, 2. So although my final graph will look like the same, but this coordinate came to left side of the quadrant number 2, that it becomes negative 2, 2. Then you could guess negative 2, 2 will be go to other side and becomes 2, 2. And you can actually think about this one actually explains one of the definition, which if you remember even function, right? Even function, you can have symmetric graph over the y-axis. So also you can remember that they are related to even functions. Then last two, let's look at next two graphs. Now I have a 2x inside. My original function was M shape, even dotted line in here. Then what's gonna happen if I have a 2 inside? That is going to make my graph shrink. So it's going to be shrink twice. That means the same thing as a compress twice. So my y value stays, but my x value is going to be get twice smaller. So if I have a 2, 0 in here, then that will give me 1, 0, and my graph is going to be this way. My y stays the same, however my x value is going to be shrink by twice, because if I plug in 1 times 2, that is same as this value 2, 0. So if you have a parenthesis inside of the function and the value when you times by 2, that will be shrink twice, or we can also say compress twice. Then this one is a little bit tricky here. So when you see 2 function of f over x, I know that this one is going to be y value and I'm going to times by 2. So just think about it logically again. I have my original function with 5 coordinates. Then what's gonna happen if I multiply twice of f over x, which represents y coordinate? So they are basically saying all the y coordinate, make sure that you are going to double it. So this y coordinate 2, 2 becomes 2, 4. Then my graph is going to be stretched twice over y-axis. So this is a stretched over y-axis. So let's summarize quickly. If you have original function, whole function add 3 will move up 3. Inside the parentheses, and careful find your zeros, then that will show you a transformation. So this move to right 2. Next one, as you see, combining these two transformations, so that shows me right 2 and then up 3. So I get this shape. Last 4, just be careful because a little bit confusing. If you have a negative outside, that means it's going to flip over the x-axis because my 2 becomes negative 2. And next one is going to be opposite as this one. And if I have my original graph, it's going to be reflection over the y-axis. So this case, since the graph is going to be same left and right side, it turns out to the same when you flip it x and x coordinate. And last two, this one is just a tricky too. 2x is going to be shrink by twice. Then if you have 2 times f function, then it's going to be stretched by twice along the y-axis. Okay. Hope that was a good practice for you. And if you look at next one, there is your in-class activities. Please pause and try quickly. Okay, now let's check the answers of example 1 of in-class activities appetizer part using transformations of your quick-count material. So if you see the red color is the answer, I will briefly go over. This means it's going to be moved down 3, and then it's going to be reflection over the y-axis. This is going to be reflection over the x-axis. And then next one is going to be shift left 3. And then last one is going to be down 2. Make sure the coordinates what you need to show me. And then you can also check with your calculator. If you got the correct answers, good job. If not, you can always ask me during the office hours. Okay class, let's start the main dish part of the 1.3. We are going to review composite functions. And if you look at f function is given as a negative x squared and g function is x minus 3. So let's compute what this composite function will give me. So let's just puzzle carefully inside of the g over 1. When I plug in 1, that gives me 1 minus 3, negative 2, and this value we will plug back to the f function. F function says whatever it has, square it and take a negative. So my answer will be negative 4. Okay, class, make sure that you understand the negative sign here. Do not just assume that that's going to be 4 or negative 4. Okay, next one. This time we are going to make a formula. If you think about coding, this is going to be same as you putting whole thing together into one equation. So let's plug in carefully. G over x is x minus 3 as a puzzle here. So I replace, and then f function means square everything and then give them negative. So I'm going to leave mine this way. I know you want to expand it, but think about if you expand it, it's going to be so many x's. So I want to keep it nice vector form. So if you actually formulate this one, then by plugging 1, you can get the answer of a again. Negative 1 minus 3 square, which is going to be negative 2 square, gives you negative 4. So this case, you programmed it into one function that any input you plug in, that will automatically get the answer for you. So if you understand this one, now I want you to pause the video for a couple of minutes and then try to do in-class activities number 2 and check answer with me. Class, now let's check the answer of in-class activities 2. And first one, see I got negative 7. Make sure when you plug in negative 2, the squares makes 4 and outside negative will make another negative again. That's an easy mistake that I didn't notice my students make it, so I just wanted to mention it one more time. And then d as a function, you can actually program it as negative x squared minus 3. Then when you plug in negative 2 in this one, you will see that you will get the same answer as negative 7 in here. If you got the correct answer, good job. If not, you can practice one more time with your homework. Okay, so example 3 is about how many functions are composed together. So if you look at A, you can actually see that 2 functions are combined together. If I want to make a circle here, I see that there's one polynomial function. It's going to be 5 minus x to the 8th power. And then I see another function combined with square root of x. So this function I can see as g composed h function. If you get to see the circles, it's going to be easy. So let's practice with next one as well. Next one, for me, I get to see 2 circles here. Then one function inside, I'm going to call it f function. That's negative x to the 4th power is inside function. Since I have a g here, I will not use g, so f, and I will use h. Function is going to be e to the, just a circle, e to the x function. So I can say that this is f, oh no, actually h composed f function. So h is going to be inside. Okay, now your turn. It's going to be in-class activities. Pause the video for a few seconds and see if you can get the answer and compare with me. Did you get enough time to do example 3? Now check the answer with me. I see 2 functions combined, and then inside function I have 5t plus 2, and then outside function is a minus a circle over 30th power, so minus t to the 30th power. And hope that it was a good review. Okay class, let's start the dessert for the day. 1.3 dessert is a little bit more challenging than other two sections that you have a practice. So let's focus together and then try to review of the inverse functions again. So find the inverse function of given functions. Inverse function means I'm switching x and y. So I know that f of x is y as a coordinate. So if I want to inverse it, I can rewrite x is equal to y to the 5th power minus 3 over 2. Then all I want to do is isolating by y in here. So let's move everything to other side. So one by one, if you look at, I need to get rid of 2, negative 3, and 5. So let's get rid of the over 2 by times by 2. I get 2x is equal to y to the 5th minus 3. Then adding 3 to the other side, I get plus 3 and y to the 5th power. I can cancel out 5th power by taking 5th root, which is the same thing as 1 over 5th power. You can take 1 over 5th power. Then I get the answer here, y is equal to 5th root of 2x plus 3. Since this one is inverse, let's indicate as inverse function. Okay, let's try one more. So next one has y is equal to 2x plus 7 over 5 minus 3x. Then I'm going to switch x and y's again. X is equal to 2y plus 7 over 5 minus 3y. This time we have 2 y's. So a little bit more challenging than previous one. How are we gonna make 2 y's into 1? So one of the way we can use is going to be factor out. So let's look at this equation. First, this equation is rational equation, which we are going to approach by cross multiplication. So I'm going to cross multiply x times 5x 3y is equal to 2y plus 7. Then by distributing, I can organize separately. And I still see that there are 2 y's here, which I need to make it 1. So I'm going to move everything to one side. So I have a negative 3xy minus 2y is equal to 7 minus 5x. I still have a 2 y's, but as I mentioned, we can now factor it out since we put all the like terms in one side. So we have a negative 3x minus 2 remains inside. Then, by dividing by your factor, I will have my inverse function as 7 minus 5x over negative 3x minus 2. Okay, here's one more for you of in-class activities. I want you to try if you can get this one correct. Okay, now let's check the answer of in-class activities. Example 4. You can see the work here, and my answer was inverse function is 14x minus x minus 3. Let's look at next result of the example 5. And let's review the rate of change, which will be the most biggest highlight of the calculus class. So let's review here one more time, and then we will review again on chapter 2 when we start the limit concept. So what is the rate of change? If you remember, rate of change is the same as a slope. Slope is rise over run, and that is delta y over delta x, which is the same thing as y2 over y sub 1 and x sub 2 minus x sub 1. They are all the same meanings, and we call as average rate of change. Another way of rewriting is f over a plus h minus f over a over h. These are also same definitions. So all these fives are the same thing. So I want you to recall that all these are representing the same meaning here. So rate of change is this. But in order to get that one, we need to figure out what is the fa plus h. So I broke it down our steps a little bit. So let's try to find a plus h here. That means my new input will be a plus h instead of x. So I'm going to replace all x value as a plus h. And I want you to make sure, practice this one a couple of times. When you do it, it will get confused. I'm going to expand this one very fast. It's going to be 3a squared plus 6ah plus 3h squared minus 5a minus 5h plus 4. So this was my f of a plus h part. So now I'm going to have a b. If you can combine, you can, but as you see, there's no like terms. But later on, when you have f over a function, that will help me. So f over a plus h minus f over a over h, rate of change. I'm going to copy down, hold the expression very carefully. This is going to be very tedious. I want to try 3-4 times. Then it will be better. Minus, I'm going to subtract 3x squared minus 5x plus 4 over h. And careful when you do this one. And careful, like me, just make a explanation carefully. Okay, careful, I made a mistake, change to a instead of x value. And when you see by rewriting every terms, a lot of expression will be cancelled out. Then you are going to have remain with other terms. So I'm going to rewrite it carefully. Don't lose your h. And we can factor it by h again. Then by cancelling out, my final answer of a rate of change turned out 6a plus 3h minus 5. As you see, a little bit long work, so you can always pause and try it. So class, let's do one more of the dessert part of the last question of the day. We want to find the rate of change, and rate of change is f over a plus h minus f over a over h. That is the slope formula, basically. So before find the rate of change, we need to compute what is f over a plus h. In this case, by plugging my original function, so replace all the x to a plus h. So I'm gonna have a 2a plus h over a plus h plus 1. So that's going to be a plus h function. Then find the rate of change. I already found this one, so let's compute them together. F of a plus h is 2 times a plus h over a plus h plus 1. This parenthesis will be same thing as addition, put it outside. And the f of a function is going to be 2a over a plus 1 here. So I write it f of a over h. As you see, this is going to require lots of work. So also look at the work very patiently. Now I have two terms need to combine common denominator by multiplying a plus 1. Right hand side by multiplying a plus h plus 1, a plus h plus 1, I can combine the denominators together. If I put together here, you see my common denominator will be a plus 1 times a plus h plus 1, a plus 1, a plus h plus 1. And in these two, I'm going to carefully put inside. So when I distribute this one, I can just do at once a plus 1 times 2a plus 2h, so that I can finish it in one foiling. So let's do foiling carefully. I'm going to get 2a squared plus 2ah plus 2a plus and 2h. Next one, you have to be careful. This is the same thing as putting negative 2a to next factors. I'm going to multiply negative 2a squared minus 2ah minus 2a. All the mistakes that my student will make is a negative sign here, so just extra careful about your negative sign. If you did all these signs well, then you will notice that a lot of them will cancel out. As you notice, all the like terms will be cancelled out, and it's gonna leave it as 2h. And as you see, I forgot very important h here, which is over h. Don't forget that. A plus 1 and a plus h plus 1. So we had a over h, but this means divide by h, which I can rewrite as multiply by reciprocal. So I can reduce one more time over h, then I will get 2 over a plus 1 and a plus h plus 1 as my rate of change. The deeper meaning I'm going to explain to you when we get into section 2.1. So let's get algebra done while we are reviewing chapter 1 for now. Here's the in-class activities, and you can try one more time similar to previous questions. Let's compare the answer of the in-class activities number 5, and these are of the last part of 1.3. And I hope that you find the rate of change and check the answer with me, and this is the answer I got.